by, you might miss it, but it's going to be trees. It doesn't have any air. It does have a little bit of frozen water, but it's hard to find. The moon is a big, dry rock. All right, come on in. Great timing. The moon is just up on the ball of lava.
It was a lava.
The moon was very hot, but it started to cool down pretty quickly. And as it cooled down, it formed rock. Now back then in our solar system, there was chaos. Other rocks would crash into planets and moons all the time. A giant rock crashed into the moon in the South Pole, creating what we see today as the Aitken Basin, a giant crater that's still there. Lots of other rocks came in and also crashed into the moon back then. 40-kilometer wide space potatoes crashing into the moon, making these deep craters on the surface. Back then, the moon still had lava underneath the surface, and so that lava filled up those craters and formed oceans of lava that lasted for millions of years. Imagine looking up at the moon and seeing oceans of lava, fiery red, up in the sky. Well, you can imagine it because today we see where those oceans once were. If you look at the moon today and you see the dark, smooth parts, the rock, that's where those oceans of lava used to be. We call them mare, which means seas. Lots of other rocks over the past 3 billion years have crashed into the moon and give us the features that we see on the moon today. The moon has been changing a lot, but it's been the same for a very long time. Our ancestors saw the same moon that we see today. And legends, and these stories in some cultures are still told today. Even though here is what our eyes see and what infrared light reveals. Again, infrared light is the light given off by heat. So if you have ever seen night vision goggles, they use infrared light. And again, looking in space in different types of light reveals different things. This is called the Karina Nebula. Vast networks of gas and dust connect together. Pockets of density form new stars, and those stars shine and cause this gas to glow. These are places where new stars and new planets, and maybe even new life, are forming. Sometimes when stars reach the end of their life, they seed new life within these stars. I'd like to show you what's going to happen to the sun in the future. Our sun is pretty stable, bigger, and a little bit hotter, enough that it's going to boil away the oceans and the atmosphere of Earth. Try not to sound too doomsday, but that's billions of years from now. Eventually, it will get bigger and become what's called a red giant star. And then, after another billion years, it's going to shrink down into a white dwarf star. Now, what I always like to say are that really big stars, when they die, they explode. Small stars, like our sun, they sneeze. This is what a sneeze looks like in space. When the sun sneezes, it's actually going to be very beautiful. It's going to form a new type of nebula that we call a planetary nebula. All the elements that made up the sun and the planets and you and I are going to fly out, away from the sun, and become parts of new nebulas, forming new stars, new planets, and maybe even new life. Let me show you a real planetary nebula in space. This is called the Helix. This is a star like the sun that has reached the end of its life and sneezed. It's quite beautiful. We see these all over the galaxy. We're going to see it in 3D as well. These are the seeds of new life in the universe. I do have to say that we've never found life anywhere else in the universe except for Earth. But I hope it's out there. And let me show you why. We're actually going to head toward the back of the dome, which is actually over here. We're going to head in this direction. And we're going to double our speed every second. Every second we're going to go twice as fast. There goes the moon. and we continue doubling our speed, we're going to fly past the sun. The sun will move past us as well. All the planets go with it.
2%, so I just kept it in my backpack.
Now, by the time I finish this sentence, we will be farther away from Earth than any spaceship has ever gone. And we still don't see stars moving. But as we go faster and faster, doubling our speed every second, we're going to start to see the stars move. Watch what happens to the Milky Way galaxy as we go faster and faster and faster. You see that streak of light in the sky called the Milky Way? Let's start moving among the stars and fly above the Milky Way. We can learn that the Milky Way is not just a streak of light in the sky, but rather another galaxy that we live in. We live within this giant frisbee-shaped structure of stars, and it's not made of just a few. Our sun is one of 350 billion individual stars flying around this galaxy. This is what it would look like if you could have super-powered eyes and really see it. We are in this galaxy. This is our home. And it is one of countless other galaxies in the night sky. Every one of these dots is another galaxy with hundreds of billions of its own stars, planets, and maybe even life. This is why we think there's life in the universe. There are, at least, so far, 200 billion galaxies that have been counted. And each one of those galaxies has its own stars, its own planets. I think it would be really lonely if Earth was the only planet with life. But as far as we know today, Earth is the only planet with life. We haven't seen life anywhere else in the universe yet. So hopefully in our lifetime, we'll get to see it. And as they explode, they concede the formation of new stars. But after that star explodes, what's left can collapse down, smaller and smaller, denser and denser, and become a black hole. Stars make their own light. Planets reflect light. Black holes absorb light. This dark spot right here, this is called the event horizon. That is the place where once you cross that boundary, nothing can escape. No light, no spaceship, nothing. Because nothing can come out of it, we can't see it. It just looks dark, hence the name black hole. The gravity of the black hole bends space and time around it. And if we could go a little bit closer, we can see how black holes warp the environment around them.